Hello, everybody, and welcome to the Astro Show, a place to be if you're curious about the cosmos. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here, you can pick the brains of astrophysicists, get advice from an aerospace doctor, find out what astronomers have to say about life, and find out what's going on up above your head, all in the same place. So, thank you for joining us this evening, and we hope to see you every time, every second and fourth Tuesday of the month normally, but third and fifth this month at 6 p.m. Mountain Time on YouTube, Twitch, and Facebook. In this week's show, we have Dr. Kevin Hayakawa, Assistant Professor of Physics at California State University, Channel Islands. Among other things, Dr. Hayakawa studies the formation and evolution of debris disks and irregular satellites. He will tell us all about that later this evening. But before that happens, let's welcome our co-stars. First, astronomer and host of her own YouTube show, Nora's Guide to the Galaxy, it's Dr. Nora Bailey.
Hey, happy to be here.
Thanks, Nora. Happy to have you. Next, aerospace doctor and founder of Orbital Biodesign, it's Dr. Danny Carroll.
Hey, everybody. Nice to see
Danny.
you.
Good to see you as well. And last, but certainly not least, astronomer and data visualization engineer from the Adler Planetarium, it's Dr. Lauren Corlees.
Hello.
Hey, Lauren. And our special guest for this evening, Dr. Kevin Hayakawa.
Hi, everyone. Thank you so much for having me.
It's great to have you, Kevin. Thank you so much for being here this evening. All right, well, let's get started with the show for tonight. And Kevin, again, thanks so much for being here. So we're going to start off with Astro Advice. And the way this works is I will read the quotation on the screen, and all of the co-stars and our special guests will have an opportunity to guess which of the four possible quoters actually said this. So here we go. If you know you are on the right track, if you have this inner knowledge, then no one can turn you off, no matter what they say. And the four options of who actually said this are A, Gertrude Elion. Gertrude Trudy Elion was an American biochemist and pharmacologist who shared the 1988 Nobel Prize in Physiology or Medicine with George H. Hitchings and Sir James Black for their use of innovative methods of rational drug design for the development of new drugs. She discovered, among other things, a drug today known as Imuron that suppresses immune response, which made organ transplants possible for the first time. B, Lise Meitner, who was an Austrian-Swedish physicist, who was one of those responsible for the discovery of the element protactinium and nuclear fission. Unfortunately, in the all too common story, only her male colleague, Otto Hahn, received Nobel Prize for their mutual discovery. C, Marie Curie, well-known Polish and French naturalized physicist and chemist who conducted pioneering research on radioactivity, who was indeed the first woman to win the Nobel Prize, the first person to win a Nobel Prize twice, and the only person to win a Nobel Prize in two scientific fields. And D, Barbara McClintock, an American scientist and cytogeneticist who was awarded the 1983 Nobel Prize in Physiology or Medicine for the discovery of genetic transposition. As of 2022, she remains the only woman who has received an unshared Nobel Prize in that category. So those are the four options for Astro Advice this evening. And whoever has a guess as to who actually said this, feel free to shout it out.
I'm going to go with D, Barbara McClintock.
All right. One vote for Barbara. I saw some nodding heads there, perhaps.
I was actually also going to go for Barbara McClintock, not because I have any clue who actually said this, but because I am a McClintock on my dad's side. Not any relation, but just I have to go with the name.
I mean, how common is the name McClintock, though? There's probably some relation there, right?
Wow, I have no idea.
Lauren, were you going with?
I was leaning towards that, but I think I'm going to switch it up, though. We'll see if this pays off for me or not. I'll change my mind to Gertrude A.
Okay, Gertrude Elion. And Kevin, what say you?
I'm going to go with B, the one choice you didn't get the award.
Okay, so we spread it out. Excellent. I appreciate that. It keeps it interesting. The correct answer was, oh, sorry, I forgot to take. That is really funny. So, when I shared the slide deck, I put a black screen over the correct answer, and I forgot to remove it for this evening before I uploaded the slide deck. It was D. It was Barbara McClintock. All right. So Danny, you got a point there. Nicely done, and Nora as well. So you are both in the lead with 1 point. Lauren, thank you so much for putting it out. And
called it. I said it wasn't going to pay off.
I feel like we can give you a point just for that.
Yeah.
All right. What do you think about this? If you know you're on the right track, if you have this inner knowledge, then nobody can turn you off, no matter what they say.
I wish I had that kind of self-confidence. I don't know if inner knowledge is necessarily the right term, but if you have confidence in it, then nobody can turn you off. But I have definitely been turned off by people and their words before. So
as have I. We are in the same camp there, Danny. Or all right.
I really appreciate this quote. Actually, I think it speaks to this sense of conviction that if you feel like you're really truly pursuing the thing that you are meant to pursue in life, then I don't know. This resonates with me. I like it, even if it may not be the most popular thing, or if all circles might not kind of see things the same way, and that's okay. So I like it.
Right on.
Yeah.
I really love it. Go ahead.
No, you can go ahead, Kevin.
I love how generic this quote is. I did watch a couple, an episode or two of this show before coming on, and in the past, some of the quotes were more related a little bit to science specifically, but I love how this is just general advice for anyone pursuing any field, whether it's astro, whether it's STEM, or any other path or direction that an individual wants to take into their career. And yeah, just good advice to follow. I can totally see this quote being on a frame.
Nice. Yeah, I can too. Lauren, go ahead, and then I have a comment I want to make too.
Yeah, I was going to say that it used to stress me out that I didn't really know what I wanted to do. What was this right track? Was I ever going to find it? And I still haven't found it. But I think what for me, I've realized over time is that I don't necessarily need an inner knowledge of this is the career path I need to be on. But what I is finding more valuable instead is an inner knowledge of what is actually important to me. So there's this idea of what are your core values? What are the things that really you hold dear that define who you are as a person? And really being able to narrow in and figure out what those are throughout my experience. If I'm unhappy or struggling with something, it's typically because one of these things that are really important to me is that friction with whatever's happening around me. And so then I can course correct to be oh, this thing that I really hold dear, I'm not receiving. So what can I do? And then that's really what I'm staying true to. So not necessarily the specific career path, but who am I? And then no one can make me not me.
Well said. I love it. Yeah, what came to me actually when I read this was what's known as the two-body problem, which is trying to find careers for you and your partner in the same place, and how that can steer you in different directions that you had not even considered before. And I mean, I'm just thinking about myself right now, right? So right now I'm splitting my time between Jackson, Wyoming and the San Francisco Bay Area. That had never occurred to me as a possibility. And it's a little crazy to go back and forth every month. But it happened because I met my partner, fell in love, we got married and had a baby. And so that's what happened. And it certainly was not the track that I was on. I was not into monthly commuting between states. So that was the only thing that struck me right off the bat is like, yeah, I can see like professionally exactly with what Lauren just said. But when it comes to matters of the heart, I'm not so sure about this, just from my own experience. Anyways, just my 2 cents.
I think it still sort of fits though. It's just a changing of what is important to you and what you value, right? And so then the track just shifts. So
the track has shifted. Yeah. Yeah.
It's not a line, it curves.
Yeah. Although sometimes I feel like it's off the track. But yeah, fatherhood. Whew.
Yeah.
All right. Yeah, it's not a flat track, that's for sure, or straight. Anyways, any other thoughts or ideas about this? Alrighty. Well, that then moves us along to Astro 365, this day in astrophysics history. So on this day in '92, Space Shuttle Endeavour completed its maiden voyage with a safe landing at Edwards Air Force Base in the California desert. And one of the cool things about this landing is it was the first time that parachutes were used to slow a space shuttle upon landing. And that became common practice, but this was the first time that that was used for a space shuttle landing. So kind of cool. All right, well, that then brings us to everyone's favorite part of the astronomy news quiz. And just a reminder that this is all lightning round. And so as soon as you think you might know the answer, you can just shout it on out. Co-stars and special guests, are you ready?
Yeah.
Let's do it.
There we go. What crashed through someone's house in New Jersey last week?
Meteorite.
There was a meteorite. Kevin, nicely done.
Whoa.
Yeah, specifically a stony chondrite, about 4.6 billion years old. All right, so
is it finders keepers? If a meteorite crashes through your house, do you get to keep it?
It like comes through your garage or your living room. Interestingly enough, we found this picture from a police department website. So maybe they did confiscate it. I'm not totally sure, to be honest with you. But yeah, I mean, I would definitely keep it if it crashed through my house. All right, so three-way tie now. Kevin, Nora, and Danny. And Lauren and Spirit as well, because we know you really want to
doesn't count. I committed to A.
Okay, here we go. NASA recently gave up on which planned moon mission aimed at shining light in shadowy craters near the moon's south pole using a CubeSat named, and I'll give you a hint, the name for this CubeSat is in the question, more or less. There are some hints there.
Is it shadow?
Something with shadow. Yeah.
Yeah.
Yeah, and what do you do
Umbra.
to illuminate a shadow? What might you use to do that?
Torch.
Flashlight.
A flashlight, and this is on the moon. So what type of flashlight is it?
A lunar
Moonlight.
flashlight.
A lunar flashlight.
Moonlight.
There was the lunar flashlight mission. Unfortunately, there were some big problems after launch, and it never made it into its proper orbit. So it's toast. It's
Oh, that's sad.
yeah, poor lunar flashlight. It is not going to do its intended mission. But was that Danny who said lunar flashlight first? I couldn't quite tell. A couple people right at the beginning together.
I think Nora did. I think I said something really stupid, so she could get the point.
All right, so we'll give that one to Nora. So Nora,
I don't know. I also went with torch first, though. So.
I said moonlight.
very, very like Australian or New Zealander of you.
I know. I blame my fiance.
Okay, so we'll call it 2 for Nora, 1 for Danny, 1 for Kevin. Here we go. Next question. First observed in 2020, astronomers announced this week that it is the largest explosion in space yet to be detected, shining for 3 years at 10 times the brightness of the brightest supernova. What do astronomers think is causing this explosion?
A gamma ray burst?
Close. It's not just any gamma ray burst, though. This one is, they've narrowed it down to something pretty specific, actually.
Like a merger?
Not a merger. I mean, it is 2 things coming together, but not a galactic merger. I think that's what you mean. It's not that.
I was thinking of like a neutron star, or like a white dwarf.
Yeah, not that.
Is there a black hole involved somehow?
There is a black hole involved somehow. Yes. Half a point for Nora. So it turns out that astronomers think that a enormous cloud of dust and gas, way bigger than the sun, is being sucked up by a black hole, supermassive black hole. And because this huge cloud of dust is so large, it has been creating this incredibly bright, basically supernova that has lasted for 3 years. And so far, that's the only explanation they have. So we don't actually know for sure that's what's taking place, but it's the best they got.
Are we seeing it like down the barrel of the jet? Is that?
I'm not exactly sure what orientation the actual image is. I mean, you just get a little point of light. This thing is like, I think it's 8 billion light years away. But yeah, like around the corner. Yeah, apparently it's the brightest single point ever observed.
Wow.
So it's just a really big AGN.
Yeah.
Cool.
Basically. Yeah, very cool. Yeah, I mean, it's, they've been studying it for 3 years and just came to the conclusion apparently last week in terms of like publication date that it was the brightest ever. So there you have it. All right, moving on. Announced last week, speaking of supernova, supernova Refstal was used to refine measurements of which universal parameter?
The Hubble
Constant?
Hubble Constant. I think Nora and Kevin got that at the same time, so you both get a point for that one. So yeah, this is a very, very cool gravitationally lensed supernova, and each of these 4 separate images has popped into view at different times, and the predicted time of it popping in was the way they recalculated the Hubble Constant, and it turns out to be in line with the lower end of the Hubble Constant, like the 66.8, as opposed to the 74 used by supernova distances. So
interesting.
That's very interesting.
If Einstein has anything to say about it, we seem to be leaning towards a lower Hubble constant than a higher one, and I tend to side with Einstein. So there you have it. Okay, so I think that brings Nora to 3 and Kevin to 2.
Sorry, can I ask a question?
Yeah, please, Danny.
So can you expand a little more? What exactly is the Hubble constant?
So the Hubble constant is this parameter of the expansion rate of the universe.
Okay, so it's a rate specifically.
Yeah, okay. And I can't remember the exact units, but it's kilometers per second per megaparsec. Is that right?
Yes, yeah, there's one way to express it, or you'll notice that there are 2 units of length in there, so they do cancel out. It could also be thought of as an inverse time.
Yeah, so it's how fast the universe is expanding at a certain time in the universe's history, because we know that's changed over time as well.
The Hubble constant is not a constant.
Yeah, How do we actually call it?
Masquerading.
Masquerading as a universal constant.
Thank you.
But yeah, this was what Edwin Hubble first teased out of the data that he was data he was looking at of distant galaxies and CP variables within those. All right, here we go. Next question. What has the JWST recently revealed in the Fomalhaut star system?
An asteroid belt.
Yeah, and not just like one asteroid belt, but like interlaced asteroid belts.
Cool.
Like way bigger than the solar system, like way bigger than the Kuiper belts around the solar system. Huge, huge asteroid belts. Way bigger than we ever thought possible, and a brand new one in close that we didn't even know existed. Yeah, nicely done, Nora. So that's 4 points for Nora. She has the lead. All right, here we go. Which planet is now the Moon King once again?
Saturn.
Saturn. Yeah.
It was like 40 new moons, and like they just dropped.
Yeah. Actually, I think it was like 62 new moons. I think that the
It was
total
an insane
now,
number.
I think the total now is 145 moons for Saturn.
That's right.
But come on, like the rings are all moons. They're just all small and moving together, right? So,
Well, I don't know if they count as moons.
I mean, they're called moonlets. They're just little guys.
But not every part of the rings is a moonlet.
I mean,
is
What's the
every grain
threshold?
of dust in orbit around the Earth a moon?
Well,
I would say no.
I don't think there's actually a defined cutoff for a moon versus something
That's
too
probably
small
true.
to be a moon. I mean, as far as I know, the International Astronomical Union hasn't actually ruled on that, like a definition of like the size of a moon.
Moon
That
versus
is-
moonlet.
Yeah. Just saying. Anyways, 145 officially recognized moons for Saturn right now. Jupiter clocks in at like 112, something like that. So Saturn is the Moon King once again. Next question. Oh, and there's a lovely picture of Saturn from the Hubble Space Telescope. Scientists announced late last month that quasars are powered by what? This was a huge mystery for like 60 years. Now they think they know.
Black holes.
Say it was a mystery.
Supposedly, it's not just black holes. Apparently, you can't get a quasar without this happening first.
Accretion?
Not exactly. What they're saying now is that you actually need colliding galaxies. You don't get a quasar without a galactic merger. And I did not read in depth about the new study, but apparently that is the deal. No galactic merger, no quasar.
Interesting. I didn't even know that was a mystery to be solved.
Yeah, me either. I don't know if I buy into this. I'd have to read the paper. I'm not convinced.
Take a look. Yeah, anyways, that's what they say. Okay, moving on. Aerospace companies Astroscale and Momentus have offered concepts on how NASA could raise the slowly descending orbit of which aging space telescope?
Hubble.
That's Hubble. Yeah, I didn't realize this, but apparently the orbit of Hubble is degrading ever so slightly. Yeah, these two companies have figured out a way to stop that. So whether or not it's actually worth it to do that with most of the gyroscopes not working, I don't know. But apparently there is a plan now.
Do you have any? Oh, sorry.
Oh, go ahead, Danny.
Do you have any insight into any parts of those plans or those suggestions that they involve?
I did not read into it, but what was the deal? They were Honestly, it is completely escaping me right now, so I don't want to say anything and get it wrong.
That's okay.
Yeah. All right. We have 2 more questions, and I think Nora has 4 points now. Kevin has 3, so it's still anybody's game. Here we go. Sorry, I just have to laugh at this one. NASA is testing a robotic blank that may one day crawl up steep slopes, slither across ice, and even slide into lava tubes.
It's a snake.
Snake.
Hey. Yeah, no joke. This is something that may get sent out to the icy moons of Jupiter or beyond. This robotic snake. It's kind of cool, and if you think about it, like a lot of the probes that have landed on Mars have had issues with getting stuck in sand traps. Like basically, it's all about like tires rolling over things. No tires on this snake. Maybe not snakes on a plane, but we might have snakes on Jupiter and at least its moons someday.
I actually got a chance to see this for
No
about
way.
this time. It was very cool.
Awesome. Yeah, I couldn't find any videos of it, but I assume it kind of moves like a snake.
Yeah, they had like fake ice that they were like testing it on. It was really cool.
This is like real ice here. This is in Northern California at some ski resort. I didn't catch which one though. All right, I think that brings Nora to 5 points. So we do have one more question, but you have a solid lead, Nora. Okay, here we go. Last question. On May 12th, flight controllers fired a mechanical device called a non-explosive actuator that delivered a shock, that moved a pin, that allowed the antenna to unfold on what icy Jupiter moon-bound mission?
Juice.
Juice! Yeah, and hopefully this GIF image is not going to play.
Of course not.
Okay, but it's a great image of the antenna unfolding that had been stuck on this little pin. Yeah, the ingenuity of these controllers, they were able to figure out how to unstick the antenna, and now Juice is a go.
I'm so glad. I had heard that it was stuck, and I didn't hear that they had gotten it unstuck. So
it was like 4 days.
Really great update.
Yeah, like 4 days ago they got it. So yeah, very, very exciting. Juice is now fully operational. All right. Well, Nora, you are our champion this week. I think with 6 correct answers, so 6 point total. Nice work, Nora.
Got lucky this week. There was actually some stories I'd heard.
You just never know what you're going to get on the astronomy quiz. All righty. Well, we've got What's Up, Dr. Sam next, and there is a fairly cool conjunction tonight, and then an occultation tomorrow morning. So if you're living in the Northern Hemisphere, you've got 2 treats coming up. Last night and tonight, kind of a cool conjunction with the constellation Gemini. Right after sunset, Pollux and Castor, the 2 brightest stars in Gemini up top, Mars just to the left of them, and then Venus down to the right. So a really nice show on the western horizon. And then if you get up early tomorrow morning, you have a chance to see an occultation of Jupiter by the crescent moon just before sunrise. It's going to be a little bit tricky because there will be some daylight. Yeah, if you're living in the right place of the United States or other places in North America, you should be able to see the moon actually pass in front of Jupiter just before sunrise tomorrow morning. So that should be pretty cool to see. Alrighty, well, it is time now for our special guest segment. Dr. Hayakawa, again, thanks so much for being here. And yeah, tell us a little bit about how you got into astronomy and what you're up to these days.
Awesome. Thank you very much, Dr. Sam. I feel like many people, I have always had a natural fascination with astronomy, but early in my life, early in my education, I didn't necessarily really have a chance to explore that fascination. I think in all of my K through 12 education, the only astronomy instruction I received was 2 weeks worth of instruction in third grade, learning the planets of the solar system. I do distinctly remember in middle school, right when the internet was like really up and coming, just like Googling different, or maybe it was even a different search engine, looking up different astrophysical objects I had heard of, like what a neutron star is, what a white dwarf was. And it wasn't even on Wikipedia that I learned about these things. It was these very low tech, low res HTML websites that I would just find just like a paragraph or two about each of those objects. And it wasn't until undergrad that I had the opportunity to really take a semester-long course in astronomy. So I took a GE survey course in astronomy at UC Berkeley, taught by Professor Alex Filipenko. It was an extremely popular class that had 800 students enrolled in one class because it was just truly fantastic, truly amazing, and really just opened my eyes to that astronomy is a subject of its own. And not only that, but it can also be a career of its own. So from taking a GE astronomy class, I then took an astrophysics class within the department, and I loved it so much that I switched my major to astrophysics, and I've kind of been on this trajectory ever since. After graduating from UC Berkeley, I went to UCLA to pursue my PhD, and I graduated from there last year. And I am just finishing up my first year as an assistant professor at Cal State Channel Islands. I've kind of continued the same research interests I've had from grad school, and as Dr. Sam mentioned earlier, I study exoplanets, I study debris disks, and the relationships of those objects with little objects called regular satellites. And a lot of these different concepts popped up in our news quiz earlier today. My thesis advisor actually sent me the paper of the JWST observations of full hat, so it's telling you the answer to that question. And these tiny moons that they continue to discover around Saturn, they're really just getting smaller and smaller in size because we found all the big moons around Jupiter and Saturn, and it's these much smaller, lumpy, potato-shaped asteroid-like moons that we're finding these days. We would call those irregular satellites, but I can definitely expand on that a little bit more later on.
Well, that is perfect. Now I really want to know, like, is there really like a clear dividing line between a moon and a regular satellite, or is like there a gray area between the two?
Yeah, so there probably is a little bit of a gray area, although I would say that I can think of at least 4 different characteristics that separate a regular satellite, such as a large round Galilean moon like Ganymede or Callisto, from an irregular satellites, and those mostly have to do with A, E, and I, as we write down the variables in astrophysics: the semi-major axis, or just you can think of as orbital radius of the moon, the eccentricity or ellipticity, the shape of the moon's orbits, and it's a measure of its deviation from a perfect circle, and then lowercase I, which stands for inclination, how tilted the moon's orbit is. And so for regular satellites, they tend to be found very, very close to the planets. They tend to be in nice circular orbits, and they tend to be coplanar, which means that the plane of that circular orbit is typically aligned both with the rotation axis of the planet, as well as the planet's orbit itself around the sun. However, irregular satellites are the complete opposite of that, where they tend to be much, much further out and farther away from the planets. They tend to have either medium to high eccentric orbits, so very oval or elliptical shaped orbits. And they tend to have essentially pretty much random inclinations. So that could mean a retrograde orbit, so orbiting clockwise as seen from above, whereas most regular moons and planets even are found to be in counterclockwise orbits as seen from above, or even just polar orbits. So instead of tracing the equator of the planet, they go above the North Pole and then below the South Pole. So there are usually pretty clear demarcations between a regular satellite and an irregular satellite.
Cool. Well, thank you. I appreciate that. But nothing about the size. So I mean, it could be something really, really big, or it could be something really, really small. But just the orbit is really what the demarcation.
Yeah, it is mostly about orbit, but size does play a factor because there are correlations between the two.
Okay.
I'm thinking mostly of the 4 Galilean moons of Jupiter, Ganymede, Callisto, Io, and Europa as just being classic examples of moons. Large enough that their self-gravity pulls them into the shape of a sphere, super nice circular tight knit orbits, beautiful, as I'm sure you all know. If you look through a telescope, you can usually see around 3 Galilean moons on average, and the fact that they all form a nice straight line with one another is a beautiful example of coplanar orbits. And as I alluded to earlier, irregular satellites tend to be more asteroidal in shape. They're small enough where their own self-gravity doesn't pull them into the shape of a sphere, so they tend to be lumpy and potato-shaped.
Very cool.
I have a question. Maybe you know this, maybe you don't. I don't know, but you got me thinking because if the planet is rotating kind of in the same plane that it's orbiting, that makes sense. That's where you find the moons. But what about Uranus? Because Uranus is really weird, where it's rotating like perpendicular almost to its orbit. Do the moons go with its rotation or with its orbit?
Yeah, that is a very fair question. I believe that the moon, the regular moons, similar to the rings of Uranus, do follow the tilt. So it's something like 91 degrees, essentially at a right angle. So the quote unquote regular moons follow the equator. And yes, there are rings around Uranus. All 4 giant planets in our solar system, Jupiter, Saturn, Uranus, and Neptune, have at least ring arcs, if not full rings around them. That's an excellent question. Yeah.
Neat. That's so weird. Thanks.
Yeah, that really is bizarre.
Yeah.
So you were mentioning earlier, Kevin, that the irregular moons, it's not the only thing that you study. You're also looking at exosolar planets. And so I'd love to hear a bit more about that, and then the connection between that and irregular moons.
Absolutely. Yeah. Thank you so much for that question. In my research, I actually mostly studied the dust that results from irregular satellite collisions. And so what that means is that in our own solar system, the moons and irregular satellites that are existing today represent less than 1% of the original total mass of irregular satellites. And that's because they have ground down to dust and released 99% of their original starting mass over the past several billions of years. In my research, we explore the ramifications of that loss of 99% of that initial starting mass, and explore the possibility that this dust could be the source for debris disks like those found around Fomalhaut, since they do indeed represent a large amount of mass and therefore cross-sectional area being released into circumstellar orbits. And actually in a paper we published last month, we show that these dust grains are quite easily able to escape from something called the Hill sphere of the planet, or the gravitational sphere of influence of the planet, and then go onto circumstellar orbits and then potentially be observable by telescopes such as JWST.
Very cool. Very cool. Anybody else have any questions for Kevin?
Yeah. Do you ever like merge your interest areas in research and do exomoon work?
Yeah, so I was actually invited here in Southern California to a local Exomoon reading group. So I'll be attending that on Friday in Pasadena. Because as I didn't even realize that. Because as your question is maybe getting at, this could be kind of an inverse or like a kind of reverse method in order to discover exomoons. We may be able to indirectly detect their presence from the fact that there is a debris disk or there is circumstellar dust in orbits around the planet. So similar to how we have indirect methods of discovering exoplanets, such as the transit method or the radial velocity method, we're hoping to prove a stronger connection between the existence of both an exoplanet and an exomoon just by observing the debris disk around the star.
That would be really cool. I am definitely so excited for the first exomoon. That's like, I can't wait. Do you have like what's your like best guess, like how long it's going to be till we like really know of an exomoon?
Oh, that is an excellent question, and maybe I don't want to go on.
Fair enough.
we won't hold you to it, but if you get it right, we'll say that he said it here for the Astro Show.
I mean, we do have some interesting exomoon candidates that, again, it almost goes back to the definition of what is a moon, versus a moonlet. But on the other end of the spectrum, what is the difference between a moon and a double planet? I think that there's evidence that there could be a super Jupiter and Neptune-sized object that are in a co-equal orbit around one another, around the star. So if a moon is the size of Neptune, it is clearly like gaseous in composition. Does that make it a really, really big planet that's part of a double planet system, or is that a moon unto itself? I guess there's no rule that says that moons can't have atmospheres, because we do know that Titan, largest moon around Saturn, has a nitrogen atmosphere remarkably similar to the composition of our atmosphere here on Earth. Or is that just a double planet system like Charon orbiting around Pluto, or some astronomers even believe that our own moon around Earth is considered a double planet system because we have such a large moon compared to the size of our planet. So interesting philosophical questions that are sometimes the hardest to answer.
Yeah, it's hard to like carve out a definition for what's a double planet and moon that like doesn't include the Earth and the moon. Like, it's an interesting question.
Yeah, I'm actually really fascinated about like the history of how the definitions of planets and dwarf planets and moons and moonlets change over time, and like the politics behind that and the discoverers and so on or so forth. I think that stuff is really fascinating. And I think the discovery of moons around extrasolar planets is going to change that yet again. I think we're going to find different types of systems and that we've seen before, and it's going to cause us to rethink what we think of as a big moon around a small planet and so on and so forth.
Yeah, we need something more like the biologists, where they have their different like Latin naming schemes, where you can just sort of branch all the way down until you get to the specific thing that you're talking about. Maybe it's becoming that diverse of types of systems, I think.
I think that would be really cool,
yeah,
actually, in astronomy.
We don't need to stick with Latin, though.
Yeah. No, that would be really interesting in physics as well. What would we do with like strange and charm quark if we went with like a Linnaean system of that'd get pretty tricky. Well, Kevin, one of the questions I haven't asked you yet is one of the questions that we'd like to ask all of our special guests, which is, what's the one question that you wish everybody would ask you but nobody ever does?
Yeah, and thank you for letting me know about this this question. So I did write something down. So we're on the semester system here at Channel Island. So it is finals week right now. My physics students just took their final this morning, and one question that I wish that they asked me more often, or even asked me at all, is, what do professors do other than teach? Because I feel like a lot of students have this conception that college and university professors are just the college and university version of the teachers that they had in their K through 12 education, but it's quite different from that. And at the university level, we usually think of our work as under three umbrellas. Teaching is certainly a large one of those umbrellas, especially at a teaching-focused university like a Cal State. But there's also research and then service. So I think most of us know what the teaching part entails, but in addition to our teaching responsibilities, we are expected to interact with the greater research community in a number of different ways, and it varies a lot by university and even departments at the same university, but publications are definitely a very, very large part of it, as well as conducting research with undergraduates or even graduate students, bringing them into the fold, attending conferences in order to advertise those publications, network, make those collaborations, collaborate with other institutions and national laboratories, and the list goes on and on. But thirdly, service to the university and the greater community, such as serving in academic senate, which is a common legislative body that universities have in order to make decisions such as what grading scale as a university are we going to use in emergency times such as COVID, what should be the university-wide policy on final examinations, or perhaps a little bit more leniency on grading and things like that, as well as a bunch of different committees within the Senate that organize things like graduation. We have a commencement committee, a budget committee, and other committees that essentially help the university function as a whole, as well as other types of service include, for example, I was a faculty fellow for an annual event called Plotathon. It's basically our version of a hackathon where students are given a data set on Saturday morning, and then they have between 24 and 36 hours in order to generate different plots, different figures, different graphs in order to tell a story, basically. So I was one of the overnight facilitators. So that was the first time in quite a while that I had pulled an all-nighter, but I did it with the students, and we all slept over. I didn't get to sleep, but some of them fell asleep in the library. So that was a really good time. So these are all different ways that faculty can get involved on campus, other than just teaching our courses.
That's awesome. And did I see, I was doing a search for you online, did I see that you were on a school board as well at some point?
Yes, that is correct. In addition to my day job as an assistant professor, I have the absolute honor of serving on my hometown school board, the Roland Unified School District, the school district that I attended for K through 12 and graduated from. I'm very proud to have been chosen by the voters, and it is just an honor to be the only graduate of the school district currently serving on the school board.
That's super cool. Yeah, I mean, I'm an educator by training, and like my PhD is actually in education. It's not in astrophysics. So I really do have a affinity towards education. And I mean, I can't imagine like the difficulty of like being on a school board and having to make those kinds of decisions. So like kudos to you, my friend, for doing that. Like I watch people who I know here in Jackson on school boards, and I know they struggle a lot. So yeah, I mean, I'm curious about that experience as well, and what that's been like for you.
Yeah, so I was actually just elected in November 2022. So I have only been on the school board for a short amount of time, but yeah, even though we both have PhDs, mine is not in any kind of education, either education or higher, or K through 12 education. So I've been doing a lot of learning and really seeing the work that really TK through 12. We have transitional kindergarten now, a grade level before kindergarten, and seeing the work that our teachers do. It's one thing to sit through class when you're a kid, but another to learn the pedagogy and the theory and the thinking behind why we teach in the way we do. So it's just been an absolute pleasure to learn from our teachers and our superintendent and our assistant superintendents on the great work that we're doing around Roland Unified. And I look forward to continuing to learn on the job, trying to make the connections where I can as an educator myself, but coming from a more higher education perspective. And really one of my goals is to bridge the gap between TK through 12 education and make higher education more accessible to our students so that they're just aware of all the different opportunities they have after graduation.
That's awesome. Very, very cool. So, I mean, it sounds like you've got an affinity towards teaching and education as well. I'd love to hear like more of your experiences teaching and kind of what your sense is of like that portion of what you do compared to the research portion of it.
Yeah. So I am very fortunate to work at a California state university. We are a public, university system here in California, but California is so big that we have multiple statewide college and university systems. So there is the UC system, the University of California, that includes Berkeley, UCLA, UC San Diego, and so on and so forth. That tends to be more research focused institutions. Have, as far as public institutions in California go, the highest price tags associated with them. And we also have the California Community College system, which is composed of more than 100 community colleges scattered throughout California. These are 2-year colleges that offer associate's degrees as well as associate's degrees for transfer. Extremely affordable. I would highly recommend, especially these days, starting out at a community college. They have great price tag associated with them. But the CSUs, the California State Universities, are kind of in the middle. We are 4-year institutions, so we do offer the full bachelor's degrees for either freshman or transfer admits, but we are very affordable compared to either private institutions or the University of California. Our faculty are much more teaching focused. That isn't to say that we do zero research at all, but we very, very much care about the student experience, have a slightly higher teaching load than an R1 or even an R2 type of university would have. So CSUs are a great option as well if you're looking for the full 4-year bachelor's degree and an affordable price tag to go along with
that. Nice. Appreciate that. Thank you. We've just got a handful of minutes left, and I always like to give the final word to our special guests. And so if you have any words of wisdom to folks who are interested in pursuing careers in astronomy or astrophysics or any other experiences that you've had on your trajectory that you want to share and anything like that, it's all you.
Absolutely, thank you. Yeah, so like many astronomy enthusiasts out there, I got started with astronomy and my fascination through watching those PBS documentaries like Nova, and they just have beautiful graphics and animations and narrators with very soothing voices who talk really, really slowly. But I would say that one common misconception that I see, or that people don't expect when they take their first astronomy class, is how much math is involved in doing astronomy. Astronomy and astrophysics are physical sciences, so we do we're essentially in a field of applied physics, so we do apply the scientific method and different quantitative methods, including from algebra, geometry, trigonometry, and even calculus, in order to make quantitative statements about the universe and the way it works. So if you are interested in pursuing a career in astronomy, or even taking your first college level course in astronomy, if you don't feel like your math skills are currently brushed up and ready for the challenge, I would just encourage you to revisit some of those skills before your first day of class, so that you're fully prepared for the full experience. Again, astronomy is a physical science. We don't only teach constellations in astronomy, and most astronomy classes don't involve pulling out the telescope every single week. I got to pull up the telescopes for my astronomy course last week, and one student asked why we couldn't do it every single week, but it would be, in my opinion, difficult to cover the entire curriculum having class outdoors every single day. So I guess that's my word of wisdom for today.
Awesome. Well, sage advice. Thanks so much. And yeah, we really appreciate you spending the time with us this evening. Thank you.
Thank you, everyone. It was a pleasure to be here.
Yeah, and our operations director, Maggie, will reach out to you with a thank you gift. So again, yeah, I really appreciate your time, and yeah, maybe I'll see you on the Astro Show sometime again.
Awesome.
Well, again, also thanks to all of our co-stars. As always, wouldn't have a show without all of you. So thanks so much for your time and expertise and good laughs. Always appreciated. Thanks to all the folks behind the scenes, like our operations director Maggie, the board of directors of Wyoming Stargazing, all of our donors, and to all of you out there who are watching this show live and who will watch the recording. We hope you enjoy it, and we hope to see you next time on the next episode of the Astro Show. Until then, be well, and don't forget to look up. I'll see you next time. Bye.
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 Bye, everyone.